And when they start pairing up, then they have to have opposite spins. But when they have single electrons in those orbitals, they'll have to have the same spin. So I'm going to go ahead and show you that. If I can find my... This is pairing. So I'm underlining this. A lot of them are having a struggle of knowing what that word means. That's pairing. So go ahead and write Hund's rule down, if you would. It looks like it's long, but it's just because I have to write real big. It's not that long.
Has anybody seen that gum commercial?
What gum?
Where he draws on all the gum wrappers.
Oh my.
Yeah,
And then they
that's a good one.
Oh
Yeah, and he like proposes to
That
her.
was a good one. That was a good one.
Yeah, like melted. By L.E.
I just kind of laid on the
Yeah,
floor and
what's
cried.
Oh, is that one electron?
One electron. Yep, 1 E minus.
Can we look up that commercial? Because I'm really curious.
Yeah, I can't see it.
Nah, dude.
Or is it like...
I like the one where the deer gets hit
By that woman.
by that woman and he's in driving.
Yeah, he's like in a
Car.
vehicle. He's like, she just froze.
Is that pairing?
Herring.
Before pairing takes place?
Oh, I saw a sad car accident one. The dude like pulls out and then like stops and then like get out of their car and he's like,
Oh yeah.
can't stop. And he's like, my kid's in the car and he's like, I'm sorry. Gets back in his car, time starts again. Yeah, that was a good one.
Road rage or what?
No, it was like.
What is that?
Can we just look all these commercials up? Because I really want to see these.
I've seen that one. No, it's
Listen.
Yeah.
He said
The one where
pairing
she's
and I didn't
texting?
remember.
That's good.
I don't know what you guys are
They have
talking
the
about.
crash,
And then she
then
like
they
goes
reverse
down.
it.
good.
She like goes down and have you ever heard down?
No, they didn't show that part.
Oh, that's a different one.
That's
It's like mine's thinking of those commercials.
I get their point across, so.
Yeah, for sure.
2005, they did that. Super Bowl game.
Yeah, that's just like whatever.
Okay, Hund's rule. We'll show Hund's rule here in a second, but Hund's rule says when you start drawing those arrows in, we draw them in one at a time. It's kind of like getting on a bus. You're first to get on a bus, you take your own seat, and then eventually there's too many people that are going on a bus, you have to pair up with somebody. Okay? And so that has to take place eventually, if that needs to be done. All right, but if it's nice to have your own leg room and own space and that, and that's what electrons, they'll tend to have their own space before they have to pair up. It's kind of like in your home, and you might not have enough rooms for everybody in your house to have your own room. And so you have to pair up. You have to pair up. That's just the way it is. Okay? So we're going to show Hund's rule. We're going to show Aufbau's principle. And Pauli exclusion principle is not really something we're going to show a lot. But when we do orbital notation, we can actually show Hund's rule too. So you had 3 to do. And this is remembering how to do these from Friday. So we start off on hydrogen, and we go through the first row. When we go through the first row, that would be where electrons are at for hydrogen and helium, and that would be 1s2. Any questions?
Which ones are those? That's high.
That's the first shell is being filled.
Yeah. Okay.
So that shell is full.
Yeah.
Then we go to the second shell. We're here. We're at lithium, beryllium. So that would be the second shell, and it'd be the S's being filled, because S's always is filled first in each shell. So that's 2s2. So now we've got 4 more elements we have to go through before we can get oxygen. So we are in the P block. And we're in the second shell because the second shell can have 8, so it's 2p4. Any questions with that?
No.
So then we draw our lines underneath that represent orbitals. Everybody knows why I include 3 lines for the p.
Because that's
3 possible orientations or pathways for the same shape.
What about with like 2p1?
that would be.
You can show 1, and that would be okay. I always just write them whether I use them or not. I write them out. That way I'm making sure that I have enough. Because if, for example, like if it was 2p4, there's 2 ways you can do it. According to Hund's rules, there's only 1 way you can do it. Some students will like to do this. Don't do this because it's wrong. And I don't want to create bad habits for you. Why is that wrong according to Hund's rule?
Because you're missing
Hund's rule says what, Joe?
They want to be individual until they can't.
Yeah, they want to have individual orbitals until they have to pair up.
Yeah.
So it should be written like this, 1 at a time, 3, 4 they have to match up at least 1 spot. What's that?
Like, ah, I got it.
Oh.
No,
Oh.
I thought you said why.
No.
Yeah. Okay. So there's an issue if you just put 2 there, because you say, well, there's 4, and I think I just need 2. That won't work. All right, next one. You had sulfur. What's sulfur or sodium? You guys had, which one was next, sulfur or sodium?
Sulfur.
Okay, sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. Questions?
Wait, okay, so P's gonna go 6?
P's can have a maximum of 6. You can't have any more.
Oh, yeah. Yeah, I know.
Harley, if you count across this block of P's, there's 6. You count across the S's, there's 2. You count across the D, or the transition elements, there's 10. So when you fill in this last part, I won't fill in the first part, but I fill in this last part.
So is it all gonna be up and down until you get to the last part?
Yes.
Okay.
All of these are full.
How do you know if they're
If they're full. The S's, if they have a 2 in front of it, they're full.
okay?
If the P's, if there is a 6 behind it, they're full. The D's have 10, they're full. But anything less than those amounts, it's not. So I want you to look at sulfur and oxygen. They all have the same ending. 2s2, 2p4. So how many, guys? How many electrons are in the outer shell for oxygen? How many electrons are in the outer shell? Okay, that would be the outer subshell, but the outer shell. 6.
2. So.
Outer shell is the 2s.
Oh, yeah.
So it'll be a total of 6 electrons. Okay. And then sulfur is right below oxygen on the periodic table. Has the same ending, S2P4. So how many in the outer shell for sulfur? They're going to act chemically alike. They're going to bond similar. Because they've got 2 openings to bond. Oxygen has 2 openings to bond. So when you look at families, they have similar characteristics when it's gaining and losing electrons or sharing electrons for covalent bonding. This is so important of a concept that, I thought I should just skip this because do they really need it? Oh, you have to know where electrons are at, where you can have pairing, where you can have double bonds, single bonds, those type of things. And we get into orbital notation to do that.
And when it goes down the columns,
Yep.
it will always end with the same one, right?
Always ends at the same one. So the P5 column would be what group number? P5. So then in P5, what group is that?
Well, that's to the right of That one.
So the P5 would be right here.
There.
So what group is that? What do we call that group? Remember? Family?
Non-metalloids.
Halogens.
Halogens.
Right?
Hey, you were close.
And then this one, these all end in P6. And these are the
Lithium.
Lithiums. What?
Noble gas.
these are the noble gases. Okay? Noble gases. All right.
Trash talk by Dalton.
1s2, 2s2, 2p6, 3s1, right? Questions on that? We're good?
These.
All right.
Hold on.
We're gonna get into having you do the configuration for argon, and we're gonna go one further. So we're gonna have you practice. Go to argon, and actually this is gonna be a configuration for potassium, which is one more electron. So you're going to do configuration for argon, and I'm gonna go ahead and put potassium. Hurry up, Dalton.
Oh.
Hey, are you doing it on these notes?
Yeah, you can just add to your notes. All of this you can go back to. These are just kind of problems that we're doing.
So we're doing.
Do potassium, but I want you to stop at argon. We're going to do potassium. We're going to label it. I want you to act like you're just doing argon though. Just act like this is AR in front and do the configuration for argon.
Okay, and do argon.
What? I don't know. Because we're doing potassium.
Alrighty.
I'm putting
Why are we stopping?
Because I need to talk a little bit about our next step after we add one more. Okay?
Oh, okay.
So this is argon. This is argon. We got one electron left to show where it's at. And it is right here. And that's potassium. What block is potassium in? What is this block? S block. Here's the D's. Those are the P's. So we know it has to end in what? S. What? 1. So we know it has to end in S1. The tendency is to write D1. Because sometimes students will go, we're going to go in this pattern. S is fill in the first, S is P in the second, SPD's in the third. But then we get back to this concept. Where's the electron going to go? 4s or 3d? Why? Because they fill up the lowest energy level. Opposite principle says we need to fill the lowest energy level first. And so that's what it will do. So it goes, so what S would that, what shell is that then? 4s1. Any questions with that? Yes?
So once we get to the D's, we still need to go finish filling the S's and then P's.
Right, we'll have to fill the S's. We're going to do that next. We're going to do vanadium. So go ahead and do vanadium. So any questions on this? Why 4s? You just have to memorize that 4s comes before 3d. But it's not hard to remember because these are the S's filling.
Which one are we doing?
Vanadium. V for victory.
Arsenic.
So do arsenic, AS. So vanadium went 3d3 because we had to fill the S first. Now, we're going to find out the most electrons that can fill the outer shell at any time is 8. It's called the octet rule. So the D's will never be in the outer shell. The D's are never in the outermost energy level. Why? Because S's and P's will be your outer energy levels, and when you add those up, it's 8. It's called the octet rule. So when we get into bonding, and we need to make sure things bond to where we have an octet of electrons, the D's are never included. The D's are left out.
So we supposed to put 3D something?
Yep.
The D's go to 10. The D's go to 10 now.
They go to 10. They go to 10.
I hit a calculator at all.
Or you can just look where you're at in the periodic table and write the atomic number down. Or see what the atomic number is.
So, if the third shell is 18, why do you only do 3s, 2, 3, 6, and go to 4?
Because a orbital of a 4s is less energy than a 3d. So what happens, electrons will start filling the fourth shell before the 3d is done. Because the 3d is more energy than the 4s.
So you always just stop at 3d.
We'll have 3ds. We have 3ds here. So you have to go through all the 3ds. What you'll do, then is you'll go back and fill all the D's out. And then you'll come back to the 4.
Okay, give me one second.
It's on the board.
You guys have been really good about the D's, how they come in, and the 4 shell has to be filled, because students will, when they do configurations, a lot of times they will not know how to compare the S's later on to the D's, and what the D's are always one behind. So when you do configurations, if you write D's after your S's, they're always going to be filling an inner shell, or the shell that you thought they would fill beforehand. They're going to go back and fill that shell. So when we do, for example, arsenic, we definitely are going to have to shorten this up, because this becomes a real problem and unnecessary once you figure out where all these are starting to come in.
Oh, I did 4D.
Okay?
Were there, oh wait, is there no 4S?
Yep.
P's.
Yep.
P's. You forgot it.
No, it's there.
It's up there.
4S?
In front of 3D.
Oh, it was, why'd you do that?
Okay? So I'm here, Cameron, right here, and this would be the 4S2.
Yeah.
Now I'm into the D's, and the D's will start filling an inner shell and go D1 through D10. And now I'm over the P's, and I got 3 to go. So P1, P2, P3 gets
So
D's.
even though it's in a different level, you just flip it.
It's finally clicking.
Yep.
Where?
Now, there are some teachers that teach this, and I always like using the periodic table as my guide, because then I'm never going to be wrong. But there's some teachers that teach this will go 4S2, 4P3, 3D10. And the way I do it is that I want to always fill the low, show you which one comes next on the energy level. So 4S is lower than a 3D, and 3D is lower than a 4P.
Is it wrong if we go like 3D10 then 4S2, 4P3?
No, as long as you know how you had to get that. Yep.
And then, will there ever be like a number 4 on with like a P and a C, or will it be one of these?
Oh, you're going to be one of these. Okay, for tomorrow, you are going to do configurations for
Which one?
let me tell you,
Oh, there.
strontium and molybdenum. Now, both of these, strontium, SR,
No, both those two, or is
Yep.
there going to be more?
nope, just those two. Now tomorrow I'm going to show you shorthand, and you're going to go, thank you very much. It'll be so easy.
Uncle Mo.
Molybdenum, MO.